Hello dear student, in previous lecture we have seen northwest corner rule problems of transportation problems. We have seen some problems on a northwest corner rule method. So in this lecture under the heading of transportation problem we will see another method, that is next method of the transportation problem, and next method is matrix minima method. We will see some problems on this method. Okay, so what is the first problem? Obtain the initial basic feasible solution of the following transportation problem by using matrix minima method. Okay, so this is the given transportation table. So this is a given transportation table where destinations are D1, D2, D3 with origin O1, O2, O3, O4. Okay, so here origin are 2, 7, 4, 3, 5, 3, 3, 1, 5, 4, 7, 1, 6, 2, 7, 9, 18. Sorry, demands are 7, 9, 18, suppliers 5, 8, 7, 14. Okay, so this is the given transportation problem. So here we have to find out the initial basic feasible solution of the given transportation problem by using matrix minima method. Okay, so what is the first step? Generally we know that we have to check the given problem is balanced or unbalanced. How will you check that the problem is balanced or unbalanced? If the summation of supply is equal to summation of demand, if both are equal, then we can say that the given problem is balanced type. Okay, so if you observe summation of AI is 34 and summation of BG is again 34, the addition of this column and addition of this row, both are the equal, that is 34. Okay, so hence we can say that the given problem is a balance type. Okay, now we have to allocate the minimum possible amount. What is the next step? Next step is, so we have to allocate the minimum possible amount from supply as well as demand. Okay, so what is the next step? So in this method we have to find out the minimum cost in a given transportation table. So these are the elements. So from these we have to select the minimum cost. We have to select the minimum element, that is 1. So here is 1 and here is 1. Okay, so we have to choose the proper element, okay, in this transportation problem. So let us we choose this element. So let us we choose this element, or for the easy understanding, so you can select this one as a ascending wise. Okay, so here one, let us we choose the smallest element is 1. Okay, so here demand is 18 and here is 8. So here we have to allocate minimum possible amount 8 to this element. Okay, so assigning this 8 to this element, then subtracting from this as well as this. Okay, so in this way, so here we have assigned the 8 and then subtract from this and from this. So here will become 0 and here will remaining only 10. So here first row will removed or satisfied, we can say they are satisfied. Okay, so after removing we get the this table. Okay, now what is next step? So next step we have to write down the other remaining elements, that is 2, 7, 4, 5, 4, 7, 1, 6, 2. Okay, so these are the remaining element. Demands are 7, 9, 10 and 5, 7, 14. Okay, so in this way, so again here we have to subtract 8 from this 34. So this will remaining only 26. So here is a 26. Okay, instead of 34. Okay, so in this way we get this table. So I already told you, we for to allocate the minimum to allocate the minimum possible amount from this table, we have to write down the remaining elements. So in this way we have write we have write we have write the elements 2, 7, 4, 5, 4, 7, 1, 6, 2. So again here we will choose the smallest element, that is 1. Okay, so here demand is 7 and here is 14. So minimum possible amount is 7. So therefore we will allocate here minimum possible amount 7 at 1. Okay, then subtract from demand as well as supply. Okay, so here 7 minus 7 will become 0 and 14 minus 7 will become 7. Okay, so similarly we can subtract from this 7 from this 26. So here only will remaining 19. Okay, so it will remaining 19. Okay, so here first column is satisfied because this column will become 0, demand will become 0. So therefore we will cross the first column. Okay, and then what are the remaining elements? That is 7 4 4 7 6 2. So these are the remaining element. So to this remaining element we have to allocate the minimum possible amount supply as well as demand. Okay, so select the smallest element from this. So this is a 2 is the smallest element. Okay, so in this way, so 2 is the smallest element. Here 7 is a supply and here demand is a 10. So minimum possible amount is a 7. So we can allocate 7 at this 2. Okay, then subtract from supply. So here will become 0 and here will remaining only 3. So this row will satisfy the from the table. Okay, as well as we subtract this 7 from this 19. So here will remaining only 12. Okay, so what is next step? So write down the remaining elements, that is 7 4 4 7, and demands are 9 3, that is 12. So this should be the tail. 5 7, that is should be the tail. The addition of the summation of A and summation of Bj should be equal. Okay, so these are the remaining elements. So here we have to select the minimum element from this table. So here 4 and here is 4. Okay, so select the proper selection by selecting a proper element, or to understand you can select this 4 as ascending wise. Okay, so ascending wise you can choose this 4. Okay, so select 4 and minimum possible amount here is 3 and here is 5. So therefore we can allocate the minimum possible amount 3 at a 4. Okay, then subtract from demand as well as supply. So here will becomes 0 and here will remain only 5 minus 3, that is 2. Okay, so this column will satisfied. Okay, again subtract 3 from this 12. So here will only remaining only 9. Okay, so here 9, addition of this supply and addition of demand should be equal. So 9 9, so hence our problem is in right way. Okay, so what are the last elements? That is 7 and 4. The smallest element is a 4, and here demand is 9 and supply is 7. So therefore we can allocate 7 at a 4 and subtract from origin from supply as well as demand. So here supply will satisfied and demand will remain only 2. Okay, so what is the last element is? That is a 7. Okay, so from this we can subtract 7. So here will only remaining 2. Okay, so here 2 2 2 and 2 means supply and demand both are the equals. So last element is a 7. So we can allocate here 2 here because demand and supply both are equal. So allocate 2 to this 7 and subtract from supply as well as demand. So this will become 0. Mean first this row will satisfied and this row is also satisfied. This will become 0. Okay, so in there 2 minus 2, so here will remain only 0. So in this way we can say that here the all the rim requirement of the given transportation problem are satisfied. Okay, so in this way we can solve the given transportation problem by using matrix minima method. Okay, now we will show all the allocations in a final transportation problem. Okay, so write down the original transportation problem, then show all the allocations uh, in this transportation problem. So this is the original table, and these 7 are the allocations: 7 3 8 4 7 7. Okay, so first we have allocate 2 at 7, then we allocate 4 at 3, then sorry, you can go step by step. You can find out the allocations of the every allocation of the elements. Okay, so we have allocate 2 at 7, 4 at 3, 1 at 8, 4 at 7, 1 at 7, 2 at 7. Okay, so similarly northwest corner rule, we can show allocations of the allocation of the in this table. Okay, then find out the initial basic feasible solution. So here x12 is a 2, x13 is a 3, x23 is a 8, sorry, x23 is 8, then x32 is 7, x41 that is 7, x43 that is 7. So these are the initial basic feasible solution. Then the total cost of this transportation table is z equal to 2 into 7 plus 3 into 4 plus 8 into 1 plus 7 into 4 plus 7 into 1 and plus 7 into 2. So if you take the multiplication and addition, so you will get the total cost of z is that is 83. So this is the total cost of the given transportation problem. Okay, so this is the first problem on a matrix minima method. Now we will see another problems on a matrix minima method. That is, problem is obtain initial basic feasible solution of the following transportation problem by using matrix minima method. So this is the given transportation table. Okay, so this is your transportation table. 1 2 3 4 4 3 2 0 0 2 2 1. Demands are 4 6 8 6 and supply are 6 8 10. Okay, now, what is the given transportation table? We can write in this way. Okay, so you can write as it is given transportation table. Okay, so here we have to check the given problems is balanced or unbalanced. If you observe here, supply is a 24. Here supply addition of this 24, and demand is also a 24. Okay, so here both are the equals. Okay, 24, and hence we can say that the given problem is a balance type. Given problem is a balance type because here summation of ai is 24 and summation of bj is 24. Okay, so thus the given problem is a balance type. Okay, now what is next step? Now we have to allocate the minimum possible amount from supply as well as demand. So for that we have to select a smallest element from the given table. Okay, so here is 0 and here is 0. Okay, so similar way we can choose the first 0. You can go ascending wise or choose the proper selection of the element. So we can choose here a 0 as a smallest element. Then we can allocate here 6. Here is a 6 and here is 8. Okay, so here we can allocate 6. Okay, so allocate 6 at 0, then subtract from demand as well as supply. Okay, so in this way we can allocate 6 at 0, then subtract from demand. So here will become 0 and supply will remain only 2. So here the first column will satisfied. Okay, so what is the next step? So in next step we have to write down all the remaining elements, that is 1 2 3 4 3 2 0 2 2, and demands are 4 6 8 and 6 2 10. Okay, so from this we have to subtract. So that is, this is a 24 24 24 minus 6. So here will become 18. Okay, that means 6 to 8, that is 18. So this is a balance type problem. Okay, so again we will select the smallest element, so that is 0, and minimum possible amount here is 4 and here is 10. So therefore we can allocate 4 at 0, then we will subtract from demand as well as supply. Okay, so here will become 0 and here will remain only 6. So here we will cross the first column. Okay, because this first column is demand is satisfied. Okay, So similarly we can subtract from this 18, that is here will only become only remaining only 14. Okay, so what are the remaining elements? So 2, 3, 3, 2, 2, 2. So these are the remaining elements. So select the smallest element from this table. So this first element we will select as a proper selection, or you can go the ascending wise to select the element. Okay, so we will choose this element 2. Okay, then we will allocate minimum possible amount from demand as well as supply. So here demand and supply both are equal, so therefore we can allocate here 6. So in this way we can allocate the 6 at 2, then we will subtract from demand as well as supply. So here first column will satisfied, and this first row is also satisfied because both are become the 0. Okay, so from this again we will subtract 6 from the 14. So here will only remaining is 8. Okay, so what is the remaining elements? So 2, 2. So sorry. Okay, so what is the remaining element? 3, 2, 2. So this is the remaining elements. Okay, so here we will allocate minimum possible amount 2. Okay, so select smallest element first, that is 2, and here minimum possible amount is 2, here is 8. So we can allocate here 2 in this way. Okay, so in this way we can allocate. So we will subtract from supply as well as demand. Here will remaining 6, so here will again remaining 6, and last element is 2, and supply and demand both are equal, so we can allocate 6 from supply as well as demand, and hence all the rim requirement will get satisfied. Okay, so in this way we can find out the we can solve the given transportation problem by using matrix minima method. Now we can so here all the rim requirement are satisfied. Now we can show all the uh, allocations in a final transportation problem. Okay, so write down the original transportation problem, given transportation problem, then show all the allocations in a to the given elements. So we have allocate 2, 6 at a 2, 2 at a 2, 6 at a 0, 6 at a 2, 4 at a 0, 6 at a 2. So in this way we have allocate a step by step allocation. Okay, so what is the initial basic feasible solution? X12 here is a 6, X23 is a 2, X24 is a 6, X31 is a 4, X32 is a 6, X33 is a 6. Okay, so in this way we can find out the initial basic feasible solution, and total cost is given as multiplication of these numbers with addition and solving, so you will get the 28. Okay, so in this way we can solve the given transportation problem. So here epsilon is tends to 0. I think here is a one allocation is a maxima uh, greater. So in this way we can choose. So you can neglect this epsilon because this will becomes a 0. So you can find out the total cost of Z is, that is 28. Okay, so this is the second example on a matrix minima method. Okay, so next lecture we will see another problems on this matrix minima method.